Okay, comparing experimental and theoretical probability. So the goal here is to identify the differences and the connections between experimental and theoretical probability. So let's recall the difference from our previous lesson. So experimental probability is probability determined from observed trials. Theoretical probability is probability determined from possible outcomes. Okay. Number one, classify each formula as either experimental or theoretical probability. The first one is experimental. Okay. How do you tell? Because the denominator, it's n of t. And n of t refers to the total number of trials. Okay. The second one is theoretical. And because, again, the denominator is referring to the number of outcomes in the sample space or the set. Okay? So recall the investigation we did on the first day of the unit. If we compare probabilities from group to group, what do you notice? When you do the experimental probabilities, everyone had a different probability. Okay, and so if you calculate some theoretical probabilities, which we're going to use just to compare for a moment, what would you notice? So the rolling a sum of 7 on 2 standard dice. So there are, if you remember the table from the other lesson, we found that there were 6 ways that you can roll a sum of 7, rolling 2 dice, and there are a total of 36 possible outcomes, giving us a probability of 1 over 6. So, or 1 over 6, or if I express this as a percentage, it would be 17%. Okay. Tossing a tails on a single coin. Well, there's only one way to get the outcome we want. The event that we want is just tossing a tails. And there are 2 possible outcomes, giving us a 50% probability of success. And then drawing 1 face card out of 2 cards in a deck of 52. Well, I want you to just trust me on this one. I'll show you how we can calculate that. It's just simply a 12 times 40 plus 40 times 12 over 52 times 51. And that's a probability of 0.36 or 36%. Now, techniques to calculate this kind of probability problem will be in Chapter 2 and Chapter 3. Okay? And number 4, so let's combine the results of the experimental probabilities. So our groups came up with different experimental probabilities, and you'd notice that they are different than the ones that you can compare up here with the 70% and the 50% and the 36%. So why is that difference? Well, experimental probability can change no matter how many times, well, depending on the number of times you perform the trials. Each trial is random, so you can't expect to get the same result as a theoretical probability. However, when you look at all the groups combined and we average them out and you compare them, you could notice that we do get closer and closer and closer to the theoretical probability. So I'm going to say here that the combined probabilities are closer to the theoretical. Okay, so in general, statistical fluctuation occurs, particularly when the sample size is small. So notice we only spent 2 minutes per experiment. We wouldn't have enough time to gather a lot of trials. So the larger the sample size, okay, or the more trials that you do, the closer you get to the theoretical probability. Okay, So meaning if you perform the coin toss 1,000 times, 10,000 times, 100,000 times, you're more likely to get closer to the 50% theoretical probability the more experimental trials you perform. Okay, and so that finishes the first part. I'm just going to load the second part of this lesson here. So the second part is looking at odds using theoretical probability to determine odds for and odds against an event. So odds. One application of probability often used in sports and gambling is odds. Odds are another way to indicate a level of confidence about an outcome that can be expressed as in favor or against. In sports, it is typically more common to give the odds against something happening. Okay, so the odds in favor is a ratio. So it's the ratio of the probability that an event will occur to the probability that it will not occur. Okay, will not occur. And the odds against is the ratio against another ratio of the probability that an event will not occur to the probability that it will occur. And these odds are given by the two formulas you see here. So the formula for the first one is the probability that the event will occur divided by the probability that the event will not occur, and that is the same thing as saying as the complement probability of the complement event. Okay, and the odds against is the probability that the event will not occur, which is the complement, divided by the probability of the event occurring. So let's look at example one. Determine the odds as indicated for each of the following events. So part A, the hockey analyst gives the Canadians women's hockey team a 75% probability of winning the gold medal in the next Winter Olympics. Based on this prediction, what are the odds in favor of Canada winning the Olympic gold? So first you have to define the event. So I'm going to say here, let A be the event of winning the gold. Okay, and then I'm going to say the probability of this event, so the probability of A is equal to 0.75. So if I convert the percentage back to a decimal, we'd say 0.75. And the probability of not winning a gold would be the complement, and that's simply 1 minus P of A, so it's going to be 1 minus 0.75, and I'm going to say that is 0.25. Okay. And so I can calculate the odds using our formula. So the odds for favor of is equal to P of A divided by P of A prime. And that is going to be 0.75 divided by 0.25, which written as a fraction would be 3 over 1. Okay. So this, I write it as a fraction. Instead of saying 3, I write 3 over 1, because if I turn this fraction into a ratio, I can get my odds. So therefore, I would say here, the odds of winning a gold is 3 to 1, like so. Okay. So, part B, a local sports journalist estimates that the TDSS boys basketball team has a 40% probability of going to the OFSA championship tournament. What are the odds against the boys making OFSA? So let's define the event again. So let A be the event that you're going to make it to OFSA. It's two S's. Oops. All right. And I'm going to say the probability of event A is equal to 0.4, and so it's a 40% chance, right? So as a decimal, it's 0.4. So that means the probability that you're not going to make it to OFSA, the complementary event, will be 0.6, which is the other 60%. So then the odds against, if I'm asked specifically for odds against, is going to be the other formula, which is the probability of the complement over the probability of the event. Okay, so I'm going to say here 0.6 divided by 0.4, and that is equal to 6 over 4, or 3 over 2 if I put this in lowest terms. So my concluding statement would be, therefore, the odds against the team going to OFSA is 3 to 2. Okay, so let's keep this in mind. 3 to 2 means there's, out of 5 parts, well, 3 parts chance of getting to OFSA and 2 parts chance of not getting to OFSA. That's what that means. Okay. So odds without calculating or knowing the probabilities. So if you don't know the probabilities, you can still calculate odds. You can calculate odds simply knowing the outcomes, the number of outcomes for an event. So I'm just going to highlight this part. If you know the number of outcomes for an event, then you can calculate the odds very easily. Okay, so I'm going to show you here example number 2, and you just use these formulas that you have here: odds in favor and odds against. And you notice n means the number of outcomes in that event. So how would I calculate this? So your pencil case has 3 red pens, 5 blue pens, and 4 pencils. So what are the odds of randomly drawing a pencil? So odds 4. I'm looking for odds 4. So odds 4 equals the number of successful outcomes of drawing a pencil divided by the number of possible outcomes of not drawing a pencil, a prime. Yeah. So I know that there are 4 pencils. So n of a must equal 4. There are 4 outcomes that give me a successful event. And then there are 8 ways. 8. So a prime would be 8 because there are 3 red pens and 5 blue pens. Those are not pencils. So then my odds 4 would simply be 4 divided by 8, and in lowest terms, 1 over 2. Okay? So therefore, the odds of getting a pencil is 1 to 2. So this, remember, keep in mind, this does not mean there's a 1 in 2 chance, meaning it doesn't mean like for every 2 items you draw, one of them has to be a pencil. No, it does not mean that. What it means is in the totality, 1 plus 2, there are 3, you'd imagine, out of 3 chances, one of them could be the pencil, 2 of them may not. Okay, so there's a 1 part chance of drawing a pencil and 2 parts chance of not drawing a pencil. All right, so finding probability from odds. So here's how you work backwards. Miss G feels that the odds of passing this course are 8 to 1 when a student misses fewer than 3 classes. What is the probability that a student with good attendance will pass the course? So again, define your event. So let's A be passing the course. Okay, so the odds in favor, so therefore, for passing, for A, are 8 to 1. So I'm going to write this ratio as a fraction, 8 over 1. And the reason why I'm writing it as a fraction is so I can equate it to my formulas. Okay, because in the formula we know is, well, odds, I'm going to write 2 D's there, so odds for A is equal to P of A divided by the probability of its complement, P of A prime. Okay, so let's equate the 2. So I can say here that 8 over 1 equals P of A over P of A prime. So I have an equation here with 2 unknowns, the probability for A and probability for a complement of A. I don't know either, but I do know the relationship exists. Okay, and the relationship is P of A prime is equal to 1 minus P of A. So I can make a substitution for this P of A. So here's my substitution is going to go up here. Okay, and if I make that replacement, I can say 8 over 1 equals P of A over 1 minus P of A. Okay, and then you do little cross multiplications. You bring this one, you bring this bracket up here, and then and well, 1 multiplied by P of A, which doesn't really change anything. But if I do that, then I can simply get a new expression 8 times 1 minus P of A equals P of A, and then solve for P of A. Okay, so going up here, if I expand the bracket, distribute the 8, I get 8 minus 8 P of A equals P of A. And so if I bring this thing over to this side, I can get 8 equals P of A plus 8 P of A, which is just 9 P of A. And then if I divide both sides by 9, then I get 8 over 9 equals the probability of event A happening. Okay, and if you take 8 over 9, divide that into in your calculator, you get 0.89, or an 89% chance of passing the course. So therefore, there's a 89% chance of passing. Okay? Now we did all that algebra, all that math, but let me tell you what. You can simplify that math a little bit, and you can calculate the probabilities straight from knowing what are the number of outcomes for the event and for the complement. So if the odds in favor are h over k, then the probability is going to be h over h plus k, and the probability of the complement will be k over h plus k. So I can use this formula to calculate the probability straight away. So here, the odds of Abdul hitting a home run are 2 to 7. What is the probability that you will see him hit a home run when you go see a game? So if my event is hitting a home run, then, and I know that the event is equal to, what was that? The event is equal to h over k, okay, and I'm going to write the ratio 2 to 7. 2 represents my h, 7 represents my k. Okay, and so in other words, think of it like the number of successful outcomes, and of A is 2 versus the number of not successful outcomes, A prime, which is 7. So the probability of event A is going to be, using my formula, the one from up here, okay, this one up here, is going to be 2, which is my H value, divided by 2 plus 7. And that's simply 2 over 9, or as a percentage, it's 22%. Okay, so therefore, next statement, you have a 22% chance of seeing Abdul hit a home run.